All right, so we're in Algebra 2. Today's lesson is 9-10, constructing sinusoidal functions. We're going backwards. Today's date is Wednesday, March 4th, 2020. I already see a hand that wants to read the objective, but only one that has a card in it. Brian.
So using 2 points from midline or stream, write the equation of the sine and cosine functions.
There it is. You said you didn't have the notes, Jane? Okay. I will print this out for you with my printer. I don't know why we're so short on notes. I don't know what happened there. Print out to... Yes.
I already did this, but Titi told me that you guys did another.
That's what it is. Okay, so it's every single person that went to softball took some of the notes already, and that's why I was short. Okay. Is there anyone else that doesn't have the notes? It's just Jaden and Leo? We finally solved the mystery. Here you go, Jaden. All right, so our general formula, once again, there it is. What does each of these letters, what do each of these letters do to our function? What is A with a quiet raised hand? Emily. A is the amplitude. Write it down. And we're going to connect that to the graph in just a sec. For now, I'm just purely doing the analysis of our equation. What about B? What does B do? Caroline? And I like how you said it isn't the period, it affects the period. Well said. I know that you're getting tired. This is probably like the 4th time that we've written this stuff down. Hopefully you're memorizing it now, though, from writing it down so much. And what is the formula for a period? If we have B and I want to find what period is, I'm assuming capital P is period. Chewy, what do I do?
It's 2 pi over b.
2 pi over b. Thank you. Ooh, I'll try a hard question, see if you guys can get it, because I haven't taught this yet. I briefly mentioned it last lesson. What is H? We don't know it. You guys know H? Sam, yeah.
Well, like, isn't it like horizontal something?
Horizontal, yeah. What's that move that means move, or the more formal word? Do you remember what it means? India?
Phase shift.
It's phase shift or horizontal shift. Exactly, yeah. Both of you, I'll take your cards. Yeah, and again, as a reminder, please turn in your cards. You can either pass it around or walk it in like Chewy just did. Thank you. So H, I'm going to write it in a different color because we haven't learned it yet. I've mentioned it. This is the phase shift, which is a fancy sounding name, and I like Sam's description of it better in terms of the layman's term, and I like how formal you were about it as well, India. Phase shift is how much we're moving our function left and right. We will learn that tomorrow. K. What is K with the quiet raised hand? Leo.
Midline.
It is indeed the midline. Thank you, Leo. And thank you for turning in your card immediately. That is our midline. All right, so I want to connect everything that we see right here in our equation to the graph. What is A doing to the graph? What is B doing to the graph? What is K doing to the graph? All right, so first of all, where's A? In terms of this graph, where I don't see any A. You said it's the amplitude. Where is the amplitude then? See 1 hand, 2 hands, 3 hands. See one of them with a card, giving you time to think. Yes, Oscar.
Would be the first dot.
The first dot right here?
Yeah.
Not quite. So amplitude is how wide the function is. This dot doesn't tell me anything about how big the function is. So what dot would it? What point would it be?
Would it be the one with the line?
This one here? Or?
Yeah.
Yeah, it is. Yeah. And in fact, it's the distance, the y coordinate of that point from the midline. So let's all label that in our notes. Thank you, Oscar. I'll take your card. This is the amplitude. It's one of those things, if I could write sideways on my stylus or with my writing pad, I would do it. It is the amplitude. It isn't exactly equal to A. Does anyone remember why it's not exactly equal to A? And I'll give you this. Sometimes A is negative. A is -2. Our amplitude is always positive. I'm talking just purely about amplitude. So amplitude is the absolute value of A, and there it is. So it's how wide our function is in terms of our extreme. What about K? What does K affect in terms of this graph? I see 1 hand, 2 hands, 3 hands, 4 hands. Do any of those have cards? Oh yeah, Loretta.
Is it the orange line?
It is the orange line, yeah. That is the midline. Let's all label it. This is the midline. I'll ask you something that I haven't really written down, but the difference between sine and cosine. Let's assume we can move our y-axis to choose wherever we want. So between this point and this point, if this was the start or if this was the start, which one would be sine and which one would be cosine? Lots of hands. Still a few people that need to get in. Look back at your notes for 9-9, or I think it's just 9-9, yeah. Look back at your notes for 9-9. If you don't know this, I'm going to cold call if I don't see someone with their card. Look back at your notes for 9-9. Yeah, Jaden. You choose either point. Dealer's choice.
The midline?
So this midline one, is that going to be sine or cosine?
It's cosine?
Ooh, it was the other one.
Sine.
Sine, yeah. Sine always starts at the origin. Sine always starts with the y-coordinate of 0. So that is the sine of x starts here. Sine of x starts here. And therefore, Jaden, this other point must be,
Cosine.
yeah, cosine of x starts here. Thank you.
Wait, so it starts at 0, 0?
So sine starts at the origin, 0, 0, and this isn't the best way of explaining it because technically I'm moving the graph now in order to make them on the y-axis. There is no y-axis, so if I assume the y-axis here, now it's a graph of sine. If I move the y-axis here, now it's a graph of cosine. Question, Larry?
Is the cosine just a part of sine?
Yeah, it is, and you can actually make a sine into a cosine or vice versa, a cosine into a sine if I phase shift it, if I move it left and right.
So you just like cut off part of the sine wave to make
Yeah. All right, and the last thing that I want to talk about is how much of a period do we have? So I'm going to do, everyone's going to hold up. How am I going to do this? I'm just going to say, I'm going to call in a quiet raised hand. How much of a period is this? Is this a full period? Is that a half period? Is it a quarter period? From here to here, how much of a period is that? Sam?
Is it a full period?
It is a full period, thank you. What about from here to here? How much of a period is that? From a extrema to another extrema, from a maximum to a minimum, how much of a period is that? Cheyenne, yeah. It is half period. What about this amount of a period right here? How much is that? Leo? Quarter. All right, cool. There's our review. Seems like we're doing really good. Thank you. So let's move on to the new stuff, the hard stuff. We have example number 1. So it's a sinusoidal function, so it's either a sine or a cosine wave. It's intersecting its midline at 0, 5, and it has a maximum at 2 pi, 9. That's all we're given. Given 2 points, and knowing it's a sine and a cosine wave. It feels like we're lacking a lot of information. It does tell you that we want to enter our function in radians also. So that means that we're doing 2 pi divided by the period instead of 360 degrees divided by the period, just like we're used to. So no changes there. All right, so let's go ahead and try to do a sketch of this. What's happening? And your sketch is a sketch. It does not need to be 100% accurate. You can modify it at will. So midline at 0, 5 and a maximum at 2 pi, 9. So off to the left here, let's make our sketch. So let's graph 0, 5. Roughly, and again, it's just a sketch. 0, 5 means 0 in the x-coordinate. I'm not moving left or right, and I just go straight up 5. We should have that point. And if you want, you can label it, that's 0, 5. You don't have to, it's just meant to try to determine if this is a cosine or a sine wave. And then finally, I have a point 2 pi, 9 somewhere else. So notice that 9 is bigger than 5. 9 is the y-coordinate, so we should have a point that is now above this point somewhere out here to the right. And it's just some arbitrary distance, I haven't labeled it, so I'm going to say right there, that's 2 pi. And I should have a point that's slightly higher. A point that's slightly higher, sure, right there. Let's call that 2 pi, 9. 9. So you have 2 options for a graph, and depending on how well you read the problem, it can be one of these 2 options. I'm going to draw both of those options. You are just going to not draw anything and try to figure out which one of them it is. So I could have a function that looks like this. This could either be a minimum or it could be a midline. So I could have something that looks like that, where that's the minimum, or on the other hand, I could have something that looks like this, where this is the midline, and I come up through this point, and that's the maximum, and I come back down this way. I will repeat that once again. This first point could be a minimum, or it could be a midline that I go through in order to get to a maximum, which means this point could be either a maximum, or I could make it into, or this would be the midline, because it goes through this point up here. So this is either a midline or a max. This is either a minimum or a midline. Which graph do I have? Do I have the orange graph or the green graph? Does there require his hand that can explain their answer, not only just answer it? India?
The green graph,
Why?
because in the problem it says the midline's 0, 5.
This is a midline. That means I go through it. It is the green graph. So everyone now copy down the green graph. Hopefully you draw it a little bit neater than Mr. Sindel. This has to be a midpoint. So it has to come up, and I'll do this in a slightly different color. It comes up through here, and that is a maximum right there, and then it comes back down. All right, so on my y-axis, I started at the midline. You can even write start. We started at the midline. Start at midline. All I'm doing right here, again, is trying to build you your parent function. Is your parent function going to be sine or cosine if we are starting at the midline? Go back up. We just did this. If we're starting at the midline, are we sine or are we cosine? Sam? Sine. All right, so let's start off our function with Sam's parent function. It's sine. We know that we have sine of x. Everyone copy it down. Our parent function is sine of x. I guess you can even just leave it sine of something because we don't know what goes in there yet, but sine of x is fine. That is our parent function, sine of x. All right, now we have to figure out what our amplitude is. Again, we're kind of going all off of our sketch here. How far do we move between our midline and our maximum? What is that distance here? Is there any way that we can figure out how far we travel to get from our midline height to our maximum height? I see one hand, two hands, three hands. Anna?
Subtract the x-axis and divide by 2. No, yeah, just subtract them.
Subtract the 2 pi and 0?
No, the 9 and the 5.
Oh yeah, the 9 and the 5?
Yeah.
Yeah, so those are the heights, and you have it correct. So if we just subtract the heights, that means it's the difference in the heights. That's literally what it means to be a difference. 9 minus 5. This distance here is 9 minus 5. This distance is 4. Again, amplitude is all about how much we're changing in our heights. We started at 5, and then we went up to 9. From 5 to 9, that is adding 4. Our amplitude is 4. So we can say amplitude is 4, and that means A is equal to 4. The only thing that will cause A to be a negative value is if instead of starting up, I start going down. Down means negative, positive, that's going up. We went up, therefore we have a positive value for A. And I'm going to write that down in the notes just in case you didn't catch it. A is positive if going up, if starting up. I can't spell. Starting up. And finally, A is negative if starting to go down. All right, and I know that this is typically about the hardest part that we're going to do now, the period. We're all scared of the period because it requires a formula. We have to figure out the period just from our sketch, just from this word problem. So first of all, can someone tell me what my formula is for period? Once again, what is our formula, Caroline?
2 pi.
2 pi over b. The period is actually equal to 2 pi over b. And we actually can figure out what the period is if we're really crafty. So remember at the very beginning when I asked you how much of the period is it from here to here, or here to here, or here to here? That's what I'm doing now for these 2 points. I can't see the entire function, so it's harder. But I know I'm going from the midline to the maximum. I know that I'm going from the midline to the maximum. I'm doing that amount of the period. How much of the period am I really doing? I only have 2 hands. I need more hands. You guys were doing really well in the period up above. How much is this? From the midline to the maximum. From the midline to the maximum, that is the, what, Sam? Quarter. Yeah. We have a quarter of the period. So we'll make a note that we have 1/4 of the period. So we can come over here to the left and we say we have 1/4 of the period is equal to 2 pi times b. But we also know how far we've traveled in that quarter of a period. How much in the x direction have we traveled between this point and this point? What is this distance right there? How can we find that? India?
Since it starts on the, it starts at 0 for the x-axis, and you go to 2 pi, it's 2 pi distance.
Yeah, there it is. 2 pi distance. 2 pi minus 0 is 2 pi. This distance is 2 pi. So we don't even know what this formula is. We can even cross it off. We did not end up using it, but we know that a quarter of the period is, as India said, 2 pi. So there's 2 paths that I can take you on right now. There's the path where you can just kind of see the answer by using the formula, and there's the path that I just use logic. I'm going to go with the logic path first, which eventually does use the formula, but it's kind of I will show you this method, and you just use it as a hammer. It'll work every single time. Just hit the formula, or hit the formula hammer with the, I don't know what I'm trying to say. Just do this process over and over, and you'll get it. We know that 1/4 of the period is 2 pi. Therefore, the entire period is what? I'm going to rewrite this line once again to make it a little bit easier to see. 1/4 of the period is equal to 2 pi. 1/4 of the period is equal to 2 pi. How do we find how much the period actually is then? Lorraine?
Is it always that 1/4 is 2 pi?
So it's only 1/4 in this case because we were dealing with a quarter of the period. Sometimes this number will be a half. Sometimes that number will be 1. It really depends on what information is given. The information that was given to us was what is the distance between, or what amount of the period do I have between the midline and the maximum? And I went back up to my graph and I said, hey, midline to maximum is a quarter of the period. That's why I wrote 1/4. 1/4 is 1/4. And where did the 2 pi come from? The 2 pi is always just this distance, your delta x, your change in x. So right now I have 1/4 of the period is 2 pi, therefore the entire period is what? Only one person knows how to do this. If I just gave you this equation right here in Algebra 1, what would you have done to both sides to solve for p? We're trying to solve for the period. Leo? Not quite. 1/4 right now is being multiplied by p, so inverse operation of multiply by 1/4 is... All right, he gives it to you, Sam.
Is it divide?
Divide by what?
4?
Not quite.
Or wait, multiply?
Multiply by...
4.
Yeah, multiply by 4 will also get rid of it. Perfect. So we're going to multiply both sides by 4. Sam sees that it's going to cross-cancel these 4s. I'm left with a period is equal to 8 pi. I know it repeats every 8 pi. And hey, I have a formula that gives me a period now. Now I'm going to finally use the formula. So I'm rewriting this 2 pi divided by b, which is the entire period, which we now found. The entire period is 8 pi. Well, the entire period is also 2 pi divided by b. So now we have another equation to solve. We're trying to solve for this b. Who can help us? I have 8 pi is equal to 2 pi over b. Our equation right here. Someone help us solve. Yeah, Lorraine.
You could change it with it. Like you put 8 over 1 and change it to a 1.
Not quite, but having this divided by 1 does help us. When I have a fraction equal to a fraction, there's a certain process that I do. Do you remember what that was?
Oh, wait, denominator is the same?
That's when we add fractions. Do you remember what this thing is called when we go like that?
Oh, cross cancel.
Not cross cancel, but cross
Oh, cross multiply.
cross multiply. There it is. Yeah, thank you. I need a quiet raised hand to help me cross multiply. Who still has their card? Ooh, Aurelio, yes. Help me cross multiply, please.
8 pi times b.
8
pi b.
pi b, perfect. And then cross multiply the other direction, please.
And it'd just be 2 pi.
Is equal to 2 pi. Beautiful, thank you. And now we're going to solve for b. I need to now isolate b. Right now b is being multiplied by 8 pi. I need to undo multiply by 8 pi. What am I going to do to both sides of my equation to solve for b? 2 hands, I see 3 hands, 4 hands. Oscar, yeah.
By
By?
2 pi.
Ooh, careful. So I want to divide by whatever's
By
in,
b.
not by b, the coefficient of b. Whatever's in front of b.
So would it be 8 pi?
Yeah, by 8 pi. And I'm not done with you yet, Oscar. What happens when I divide both sides by 8 pi? I want to make sure you know what's going on here.
Well, 8 pi gets cancelled out.
Beautiful. And then what's left on the left-hand side?
B equals 2 pi over 8 pi.
There it is, 2 pi over 8 pi. Thank you. Yeah, so we've canceled it out. And one additional step, we're going to simplify this 2 pi divided by 8 pi. Is there another quiet raised hand that can do that for me? Yeah, Sam.
Is it just 2 pi? Because wouldn't you simplify the 4 pi?
What do you mean by that? You simplified the 4 pi?
Oh wait, never mind.
Okay. Is there anyone else that can simplify this for us? Sam, you can call on whoever is raising their hand right now. You can look around.
I'll give it to you.
Okay.
The pi's cancel out,
Pi's are gone.
and 2 and 8 can both be divided by 2, and that gets 1/4.
1/4. There it is. Thank you. Whew, that was hairy. I know, it was hard. Whew. That was the hardest part. We're on to the easiest part now, which is finding the midline. The period b is equal to 1/4. We know a is equal to 4. We know our parent function. The only thing left in our original function all the way up, where did it go? Up here is our k, our midline. So k on the midline, it will always be whatever your y-intercept is. Your y-intercept is always going to be your value of k until we talk about phase shift. So I'm kind of half lying to you. So midline, can you please write in your notes y-coordinate of the y-intercept? And if you want to simplify that and be a little bit informal unformal about it, you could just say it's the y-intercept, because most people say y-intercept is 3. It's really 0, 3, but yeah, the y-intercept. So what was the y-intercept in this case? I can jump back up to my graph. What was our y-intercept? Cheyenne? 5. K is 5. Done. Take a bow. You've completed all of the pieces. We just need to put them all together, and we have our formula. So come down in here, write down Cheyenne's. K is equal to 5. All right, build it piece by piece, brick by brick. The first brick is A, and I'm going to write that down. A is 4. So I write down 4. What was our parent function? Our parent function was sine. Okay, what's going to go inside here? This is going to be the b that affects the period. So b we wrote over here. Maybe I should box all of my variables so I can actually find them. So I have b is equal to 1/4, so 1/4 of x, and then finally plus k plus 5, and box it. Whew, that was a bit of work, and it is going backwards. but there it is. You have created a formula from purely 2 points. And I will say one final thing before I let you try example 2 with a group. There are definitely more than one answers. There's an infinite number of answers. I could have done this with cosine, as kind of Lorea was pointing out earlier. It would have been harder because I probably would have had a phase shift. I could have done this with sine with different values also. Although I think that might have to still have phase shift. Generally speaking, there's probably going to be one easiest answer though, and it will look kind of like that. Okay, you guys need to ask me questions because you're about to go off by yourself into the mathematical wilderness here. Any questions before you move on to example 2 where you try it on your own or with groups? So Lorraine, then Jaden?
So, how do you know if it's a sine or cosine?
Yeah, great question. How do you know if it's sine or cosine? I'm going to give that to someone else. How do you know if it's sine or cosine? After we made the sketch and we compared it to up here, how do you know? Yeah, Sam.
It's sine because it starts in the midline.
There it is, yeah. Sine will start at the midline. Cosine will start at the minimum or start at the maximum. Or minimum or maximum. Question on top of that before we get to Jaden? Yeah.
No, that was my.
Oh, that was yours? Oh, perfect.
It's just, I don't know.
And that's how it works. One person asks a question because
That diagram down there.
others think about the same question. Yeah.
So, how do you know which, like, where the midline is if there's no graph?
If there's no graph, you have to make a sketch. 100% of the time, I highly recommend making a sketch because with our sketch, we can see that it crosses the y-intercept here. It will always give you a y-intercept.
So the midline is just where it crosses.
Yeah, where it crosses the y-axis.
Okay.
There's 5 in this case. Yeah, good questions, good questions. Keep them coming. All right, I'm going to be circulating in the classroom, helping you with example number 2. Oh, question before we begin?
I'll just when you're done.
Okay, cool. We are working on example number 2. After you check with either me or a neighbor, hopefully a neighbor, and you get the same answer, you may move on to the homework on Khan Academy. All right, this is my recording hat now, and it is currently on. We are finishing up example number 2. Some of you might have finished this from yesterday. We have a minimum point at 0, 1 and a maximum at 4, 7. So very similar to the warm-up, very similar to all these. Thank you. Very similar to all of these questions that you're going to be doing for homework. Sketch it. Sketch it is your first step. And make it as big as physically possible. So I know I don't have very much room. Oh, we have all this room down here. I'm going to use this room down here. So I'm going to make a gigantic graph.
What is this about? 9 dot what?
This is 9-10.
Oh, I don't even know.
Do you want me to print out some notes for you?
No, I just lost it.
Would you like me to print this out for you?
No,
Are you sure? It takes me like 2 seconds.
no.
Yeah, you should.
Why are you talking?
Why are you talking?
Okay, that was rude for both of you. Please stop. All right, so from here, I'm going to graph 0, 1. I'm going to make it kind of large, and then 4, 7. So let me move this line down. 0, 1 is right about there. And I'm going to say 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I actually have the perfect amount of room for this. So this is now actually to scale. That's pretty cool. And I'm going to label these points to 0, 1, 4, 7. So this was the point 4, 7, and this is the point 0, 1. Again, they should always be giving you a y-intercept. That will help you determine what type of parent function you have. All right, and I'm also going to label what these things are. 1 is a minimum. So 0, 1, that is a minimum. I will label that minimum. And 4, 7, that is its maximum. So I come in here in my graph and I say, this was, zoom in, there you go. This is a point of max. Now that they're all nicely labeled, I should be able to make my graph. As we saw in the warm-up, the incorrect way of doing it is going through this point and doing something, and the incorrect way of doing it is like going through this max. That is the turnaround point. This is the turnaround point. In fact, you could probably sketch the turnaround point first, sketch this turnaround point first, and then kind of connect these lines, and then you'd get a nice little graph there. The important piece also isn't the fact that that's the turnaround point, but also where is its midline, approximately. And we can say, well, just eyeballing it with this sketch, I think that the midline is right about there. And it probably will be, because those are nice numbers. 7 and 1, subtract them, it's 6, yeah. Well, you add them. So 7 plus 1 is 8, and then half of 8 is 4. So 1, 2, 3, 4. Yeah, that is actually its midline. We discovered it just from our sketch. The first step after we make our sketch, after you don't even need to have the exact midline, but just a sketch of it, is to find the parent function. Did we start our y-intercept at a minimum, maximum, or on the midline? And we clearly started at a minimum. With a quiet raised hand, finally getting some participation now. Is this cosine or is it sine, and why? And the first person I have to call on is Atziri. She didn't participate yesterday. It is indeed cosine. So everyone write it down. Thank you, Atziri. It's cosine. So Atziri, I'm not going to ask why it's cosine, but what would change in order for this to be a sine? If I wanted this to be a sine of x, what would have to change in our sketch for this to be sine of x? In terms of the y-intercept. This point wouldn't be here, it would be somewhere else. What would make this a sine parent function? You have one of 3 choices. You have point 1, 2, and 3. So which of these 3 would make it a sine function? Not quite. So 1 is still a maximum. So either a maximum or a minimum is cosine. Therefore, 2. Yeah, anything on the midline will make it a sine graph. Yeah, thank you, Atziri. Sorry to put you on the spot like that, but thank you for participating. All right, so we know that it's cosine of x. Our amplitude, let's figure that out next. I guess we did the period first or after our parent function in the warm-up, but that's okay. So our amplitude, how far did I move between these 2 points? Well, I did 7 here, 1 here. I subtract them. I get 6. So the answer is 6, right?
Yeah.
The answer is not 6. The amplitude is not 6. Someone with a quiet raised hand, tell me why it's not 6. All we did was we took the y-coordinate of the first point. We said 7 minus 1, that's 6. So the answer should be 6. Why is that not true? India, talk to us.
Because 6 is both sides of the amplitude for both the drop and the
Yeah, it's that whole distance. And what is the amplitude actually asking for?
it's asking for
Half.
from midline to one of the extrema.
Yeah, so it's this distance here or that distance here. That's the distance I'm looking for, which is half. Perfect. So we take half of that, and the amplitude is 3. But then the question is so this is amplitude, but now I'm saying, what is our value of A? A is equal to 3 or negative 3? And again, let's write this down off to the side. If I start at a minimum, if the start is a minimum, it's going to be a negative cosine function. If the start is at a maximum, it's going to be a positive cosine graph. Ooh, then what would be the difference between a positive and negative sine graph? So we're going to add a little bit more to our notes also. So if our start now, let's change to a different color. Hopefully everyone has this written down. If our start is a minimum, it's a negative some number cosine of x. If the start is a maximum, it is a positive some number cosine. What if our start now, how do we make the start such that I have a positive sine of x? And then vice versa. What happens to make it so that I have a start function that is a negative sine of x? Again, negative some number. It could be negative 7, negative 8. I'm just saying a negative. So what's the difference between sine and negative sine? Can anyone distinguish between like the two? I don't know why I said like there. Minimum and maximum were the ways that I could distinguish a negative cosine and a positive cosine. How could I distinguish between a positive sine and a negative sine? I see one hand up. And I'll give everyone a hint because it looks like we're all struggling. Look at your parent function. And I guess the parent function from notes 9-9 would be easier to look at. Look at the difference between sine and cosine. It's a little bit confusing here. Cosine starts there, sine starts there. But more importantly, sine starts going this direction. I just got unplugged.
What up? You have 100%.
Yeah, but I want 100%.
I'll bring it.
What's the difference then between sine and negative sine? Ellery.
The sine wave starts going up, like in a positive direction.
direction.
Everyone write it down.
Graph.
Goes up. And then, therefore, the vice versa of that Ellery, negative sign
It
goes
goes down.
down. And I'll put a note here, it goes down from the midline. So it goes up from midline. And then the start goes down from the midline. And I ran out of room here, so I'll just say from the midline over here. Yeah, I'm realizing that those notes are nice and messy, and I don't like it at all. I will definitely make an improvement for the next set of notes. But I'm not going to reteach this lesson for you guys because I think this is still an okay lesson.
I have a question.
Question, Beverly, go.
Were the first, there was like ones that you did before,
Yes.
like when you didn't do it, like you didn't do the video, but you had to fill out notes
Yes.
on the website.
Yes.
Was that different?
It was slightly different, yes, than these because I haven't done these yet.
Does that mean this is
This one is improved and slightly better. But it should be the same. It's still the same math. I'm just better at teaching it than last year.
It was like different math.
I guess I could look at what exactly I taught last year. Because is this what you saw from last year? This is the notes that I had from last year.
Yeah.
Maybe you could analyze what's different as I keep doing this problem. So, from here, let's figure out the period. How do I figure out the period? I already gave us our formula. Someone help me fill in that formula. Fraction of the period is equal to your change in x. And then after I do that, set that equal to 2 pi divided by b. So,
How do you decide if you're starting, where the starting point is for the cosine? Like, didn't we start at the minimum, so it should be a -3?
if we start at the minimum, oh yeah, we never actually answered it, did we? The answer is -3. We got all those notes and we didn't come back and answer it. Yeah, the answer should be
Which one is,
-3.
like the first point from
The y-intercept. So these are all the y-intercepts.
Okay, the Y-intercept. Okay.
The y-intercept, which I'm really calling the start. So if your y-intercept is a minimum, if your y-intercept is a maximum, if your y-intercept is a midpoint that goes up, if your y-intercept is a midpoint that goes down, that will affect if you have a positive or negative sine or cosine.
So amplitude is -3.
Amplitude, well, amplitude is 3, A is -3. Yeah.
A is negative.
Did I do it wrong last year?
A, you said it says A is -2.
Don't know. Yeah, those notes are wrong. Sorry. You can log the extra credit point because that's a teacher error, even though it's from last year. I'll give it either way. Same thing for those of you watching in the future. You guys can say hi to the current geometry class right now, right? Or current algebra 2. No, yeah, current geometry class. Okay, so someone help me fill in this formula. What fraction of the period am I given right here? Between a minimum and a maximum. This distance right here. How much of the period? Is it a fourth? Is it a half? Is it 3/4? That'll never happen.
Quarter.
Is there a choir's hand, Aurelio?
It's a quarter.
Good guess, but it's not a quarter. A quarter would have been a midpoint. So this distance right here, Aurelio, is a quarter because it goes from a minimum to a... It is indeed a half. So I have half the period, and I set that equal to delta x. So the change in x. Well, how far did I move? I went from 0 to 4. I'll do some really sophisticated math for you. 4 minus 0 is 4. So I'm going to say that's equal to 4. Okay, well, if half the period is 4, what is the full period? The choir's hand? Yeah, Lorea. It is indeed 8. Mispronounced that. Yeah, I multiply both sides by 2, multiply that side by 2, multiply this side by 2, and I get period is equal to 8. And now, once I have the full period is 2 pi over b, so I can now say 8 is equal to 2 pi over b, and then I can solve. Again, the way that I showed you guys in the warm-up was a cool little trick. In order to solve this nice and fast, is I treat this as a fraction divided by a fraction, or a fraction is equal to a fraction, and then I just swap the diagonals, which is mathematically equivalent to dividing both sides by 8 and multiplying both sides by b. Beverly.
Where'd you get 4 from?
4. 4 is the distance, our delta x. How much do we change in our x direction from 0 to 4? We did 4 minus 0 and we got 4.
And multiply by 2 because it's half, right?
Yeah, half of the period. So in order to get rid of half of the period, we multiply both sides by 2, and now this is all gone, and period is by itself is equal to 8. All right, and coming over to our trick, I just swap these two, and now I have b divided by 1, which is just b, is equal to 2 pi over 8, and then I can simplify that to pi over 4. So we finally have our value of b. I'm going to box it because we're going to need that value. It's kind of hard to see all of my work here is scattered. And then finally, the easiest thing to do is to find the midline. The midline, I take the y-coordinate, I'll call this the y-coordinate of 1, I'll add it to the y-coordinate of the other one, and I'll divide it by 2. You really want to be thinking of the midline as the average y-coordinate. What is the average y-coordinate between this coordinate and this coordinate? To find the average, you add them together and then divide by 2. So the y-coordinate of 1 and the y-coordinate of the second one divide by 2. So I'm really saying here 1 plus 7 divided by 2, that's 8. That's 8 divided by 2, and that's 4. So I say 4 is equal to k. K is our value for our midline. We have math happening all over here, but let's put all of our pieces together. Is there a quiet raised hand that can do that for us? I have everything written up here correctly, I think. Yeah. What is our final answer? Yes, Jaden, go for it. First, start with A. There. I'm really bad at doing math on that one. Yeah. What is A, Jaden?
3.
Careful.
3a.
Negative 3.
Oh, that's right.
Negative 3.
Sine. Cosine.
Cosine.
Equals pi over 4 or something like that.
Yep, pi over 4. So cosine pi over 4. Pi over 4 x. Yep.
Plus. What's the h come from again?
It's the k value, right?
No. Okay.
We don't have an h value in this one. We haven't learned that yet.
Why is there in this one?
Up here, I cross it off in these notes. Where did I have that? Oh, I didn't cross it off. I just said phase shift. I should have crossed it off.
And then 4?
Plus 4. Final answer. Box it. Yeah, Loretta, question. Is the question about the negative or the 3? Both? Okay, sounds good. So, let's see if someone else can explain that. Let's give it to Beverly. Yeah, where did negative 3 come from? I'll help point stuff out. I will be your pointer. The amplitude was negative 3, but where did that negative 3 come from?
7 minus 1.
Where did 7 minus 1 come from?
X.
Y
The y coordinates.
Okay, we subtracted them.
And divided by 2.
So it's the distance here, but half the distance.
You always divide by 2?
You'll only divide by 2 if I give you 2 extrema. If I only gave you a midline and an extrema, well, that is the distance. I don't need to divide by 2. This is the distance that was given. This is the distance that was given, so I had to cut in half. So not always, half the time.
Why is it negative?
Why is it negative? Someone else answered. Yes, India.
Because you started at a minimum.
Oh, there. No, there. If you start at a minimum, which we did, it's going to be a negative cosine. And then if you start at the maximum, if you're starting at all those. All right. So I know the types of scores I'm going to be getting, but I'm still going to ask it because I'm curious. Our objective today, our fist of 5, how well can you use 2 points, and I'll choose one from the midline, one from the extrema, or one from the extrema, one from the other extrema. How well can you write an equation for sine and cosine with no phase shift? How well can you do today's and yesterday's lesson? I'm rounding down to the nearest whole number. So if you give me a half, I'm just gonna say 2, 2, 2, 2,
I almost
2,
got it yesterday,
2,
but, like, you told me I was wrong.
2, 2, 4, 2,
Wait,
2, 3, 2, and then 0. Okay. Thank you, guys.